Okay, sorry again for the fuzzy graphics, but we're back at example 6, and it's asking us to simplify the following like last time. Well, A says, what if we have the square root of 5 minus 2 times the square root of 3 times the square root of 5 plus 2 times the square root of 3. If you remember from our last example, we talked about expanding these using the FOIL or box method. If you use the box, it's the same thing as FOIL. I'm going to use FOIL because that's what I like to do. And so by foiling this, I should have square root of 5 times square root of 5 makes 5. Square root of 5 times 2 times the square root of 3 makes a positive 2 times the square root of 15. The inside is going to make a minus 2 times the square root of 15. And our last terms, okay, so there's a negative. So that holds, right? If there were 2 negatives, it would be positive. So you've got a negative. You get 2 times 2, which is 4. And the square root of 3 times the square root of 3, which is 3. So this makes a minus 12 overall. Now, if you multiply this out, so we've got these two terms cancel, and then we just have a negative 7. So it can actually simplify to something depending on the arrangement of our different terms here. Now B says, what about if we say 5 times the square root of 7 plus 3 times the square root of 2, and what if we square that? Well, remember, this when we have addition between terms and we're squaring it, it makes more terms than it looks like, right? It makes a square. So instead of one term that's squared just makes one term. But if you have 2 separate terms and you square it, it makes 4. So like the FOIL or the box. If you have 3 terms that are separated squared, that makes 9 things. Now some of those may combine later to kind of cancel each other out, but you're going to have those to start. So here, what I want you guys to practice is, how can I do this without making the box? Or how can I do this, or how can I just automatically jump into what I'm working on? Well, tie this back into the example previous, okay? What you're looking at is just a condensed version of that. So I want to do insides, I want to do outsides, and I'm going to do last. So the first terms here would be 5 times the square root of 7 squared. So I have to multiply that by itself, which that's going to make 25, so 5 squared times the square root of 7 squared, which is 7. So 25 times 7 makes 175. Now, these two terms represent not only the outsides but also the insides because of the way that it would stack together. So I actually end up doubling these. So 2 times this. So 3 times 5 is 15. The square root of 7 times the square root of 2 is the square root of 14. So I get 15 times the square root of 14. And then finally at the end, it's just the last, so it's going to be 3 square root of 2 times 3 square root of 2, which makes 3 squared times the square root of 2 squared. That's 9 times 2, which is 18. And at the end of the day here, we have 193 plus 30 times the square root of 14. Nice, easy, clean answer. We can find it. It's just about making sure that you know what is expected when the operation is taken out. Don't do the easy thing by just squaring the first term and squaring the second term. Realize that there's a combination of the two that is there because we have the separation of terms by addition.